so moving on to the actual problem, so we're going to use those principal values and the ranges that we have. So if you look at number 1, where it says arc sine of negative 1/2. Okay, so first thing you want to do is we want to rewrite this. So if it says sine to the negative 1, or if it says arc sine, remember that just means inverse sine. So to rewrite it, you're going to write it as sine theta equals, and it's going to equal whatever's in the parentheses, is equal to negative 1/2. So arc sine of negative 1/2 means the same thing as where is sine theta equal to negative 1/2. Okay. So we know that sine is the y value on the unit circle. So we're trying to look for when a y value is equal to negative 1/2 on our unit circle. Now, here's the part where you have to use those graphs. So principal values tell you the only places you can find your answer for inverse trig functions on the unit circle. So if you remember, the principal values, if you need to look back, for arc sine were from negative pi over 2 to pi over 2. Okay, so let me pull up the unit circle. So remember we said negative pi over 2 to pi over 2 would be in quadrant 1, or that it could be found in quadrant 4. If it's in quadrant 4, I'm going to circle that. We're going to have to do something special to our answer because our answer will have to be between these two intervals. Okay, so look at on your unit circle, only in quadrant 1 or quadrant 4. We're trying to find where the y value is negative 1/2. So it's not going to be in the first quadrant. Those aren't negative. But if you look down here in the fourth quadrant, at 11 pi over 6, that value is negative 1/2 there for the y. So 11 pi over 6 is where this happens. Okay, so let me explain why we have to fix our answer. Our answer has to be between negative pi over 2 and pi over 2. 11 pi over 6 is way too big, okay? So because that was in quadrant 4, we're going to have to find the coterminal angle that would be between there. So because this is too big, we need to subtract 2 pi. Okay, and if we want to make them have the same denominator, we could subtract 12 pi over 6. So our final answer for this is going to be negative pi over 6. Okay, so for arc sine and for arc tangent, because they're very similar, you're going to be looking in quadrant 1 or quadrant 4. If you end up in quadrant 4, you will always have to fix your answer because it's going to be too big, and it has to be between your principal values, which was that range that we got from the graph. Alright, so let's go back and look at number 2. So 2, we have the cosine negative 1 of 1. So this is the same thing as writing this. This is the same thing as writing as arc cosine, but it's just cosine to the negative 1. So the first step you always want to do is rewrite this. So that this means the same thing as saying cosine theta is equal to 1. It means the same thing. Alright, we know that cosine is the x value. So we're trying to find on our unit circle where x is equal to 1. Now, because we were doing inverse trig functions, we have to look at the principal values. The principal values come from the range of the graph of the arc cosine. So the range on that graph was from 0 to pi. And if we take a look at our unit circle, from 0 to pi, we're looking in quadrant 1 or quadrant 2. Now, the good thing about arc cosine is that quadrant 1 or quadrant 2 is going to give you your exact answer. You don't have to do any fixing at the end. So we are looking between quadrant 1 and quadrant 2. We're trying to find where the x value is 1. So if you look here, the x value is 1 when we're at 0. So 0 is going to be our answer. And if you want to double check, 0 does fall on the bracket, so that means it can be included, so that's why it's 0. Alright, so if we go back, let's look at number 3. So for number 3, we're working with arc tangent of negative 1. Okay. First step is always to rewrite this. So this is the same thing as saying tangent theta equals negative 1. Alright, we know that tangent is y over x. And we know for y over x to be equal to -1, that's when we would have to have the square root of 2 over 2 in the numerator and denominator. And then one of these could be negative, either the top or bottom, we're not sure. Okay, so we're looking for when I have that same coordinate, square root of 2 over 2, square root of 2 over 2. Now, because we're working with inverse trig functions, we have to worry about the principal values. The principal values for arctangent are just like arcsine, except for instead of having brackets, it has parentheses. So from -pi over 2 to pi over 2. Which means, if you take a look at your unit circle, we're going to be looking quadrant 1, or we're going to look at quadrant 4. Just remember, if we get something in quadrant 4, it's going to be too big, so we have to fix it. Okay, so looking at your unit circle, look at quadrant 1. So for quadrant 1, if you take a look at pi over 4, those are both positive, so it wouldn't give you a -1. So we're going to have to look down here at quadrant 4. So if you look at 7 pi over 4, that'll give you, when you divide those, that will be -1. So 7 pi over 4. But because it was in quadrant 4, it does not fit in our interval, it's too big, so we're going to have to subtract 2 pi. So if we make our denominators the same, we subtract 8 pi over 4. So we're going to end up with -pi over 4 for our final answer.